So machine learning models are picky. They can't read text and they struggle with numbers that are too big or too messy. So that is where feature engineering comes in. Today we will explain 4 essential techniques, 2 for categorical and 2 for continuous numerical data, right? So first for categorical data techniques. So first, how do we handle text? Technique 1 is one-hot encoding. This is a nominal data thing with no orders like colors and so on, right? So here we can see that in the one-hot encoding we have labeled, right? The red, blue and green are labeled as a matrix of 3 by 3, right? So as the number of things increases, the matrix increases in terms of that, right? The next is the label encoding. So this is for ordinal data, things with an order like t-shirt sizes and so on. So here we can see that small o code block, here we can simply assign numbers. Small is O, medium is 1, large is 2. The model understands that 2 is bigger than 0, which captures the logic of size perfectly, right? Then comes the continuous data techniques, right? Now, what about numbers, right? So the third technique is min-max scaling or normalization. This squashes all the numbers into a range between 0 and 1. This is crucial for algorithms like neural networks that fails if input have vastly different scales, like age versus salary, right? The age is from 0 to 100 and salary could be in lakhs or crores. The fourth technique is binning. Sometimes exact numbers are noise. You don't care if someone is 18 or 19. You just care that they are teenagers, right? So binning converts continuous data into buckets or groups, right? So all the teenagers comes in a one bucket, then adults, then the people who are above 50 and so on, right? So the next is let's just visualize the continuous technique with a chart, right? So if I click on the raw data, right? If I click on the raw data here, the raw age of 10 users ranging from 18 to 80. The scale goes up to 80, right? Now if I click on the min-max scaling, we can see that the shape of the data looks identical, but look at the y-axis. Everything is now between 0 to 1, right? So it uses 1 as 80 and 0 as the user, right? The third is the binning. So we group them into young one, middle-aged and senior. We lost the exact ages but gained clear simple categories. This makes the model more robust to small variations. So in conclusion, we can say that we can use one-hot encoders for colors, label encoding for sizes, scaling for neural networks and binning to simplify the noisy data. So this was all about this video. Thank you.